Welcome to Insight Builder channel. Pytorch experts, Python enthusiasts, and my dear friends. Exploring Pytorch on Raspberry Pi. Hands-on tensor data manipulation for AI enthusiasts. This is part 3 of multi-part video series where we are taking a look at the Torch module and its various sub-modules that help in building the AI models. We had looked at the various data creation functions here. So we have already seen this in earlier videos. We also saw how we can use VS Code, also Jupyter notebook extensions like Hinterland to work with all these methods with Torch inside Raspberry Pi. This is one of the key aspects of these series of videos. All the Torch transformations, data creations, as well as the experimenting is done in Raspberry Pi 3 plus B version board. This video we wanted to enter into data manipulation, that is matrix and tensor manipulation. There are various operations like matrix multiplication, operator broadcasting, mask fill, concatenating, stacking, squeezing and unsqueezing, and a lot more. But these are the main methods or functions that we have to become fluent. In order to move ahead and do the matrix multiplication, first of all, important point is we have to find a way to visualize the matrix. When I started looking for options to visualize matrices, I had looked at various options that is already available in Python, and there are in fact lots of options like PyMesh. We have Turtle, we have Pytorch 3D, we have VisPy, and we have Solid Python, and so on and so forth. But my primary challenge here is to visualize the matrices. These are going to be a kind of a mesh. As I was exploring and looking at all these options, I came across one interesting blog. That is where I realized that I got the answer. So this particular blog has been written by Basil Homer, and he talks, he knows what matrix multiplication is, and he has got an excellent tool for that, and it's an online tool. You don't need to even have it offline. It's already online, and it's called as matrix, it's called as and once you look into that, you will see it's actually a 3D Matmul visualizer. Whatever you are seeing here, this is based on the link that I clicked on this location. And once you click this, it will provide you the entire reference as well as what this particular tool can do for you, and a lot more stuff. The point I want to make in next couple of minutes is that we have to understand how to use this tool. Believe me, it is going to make your life, if you are starting as a new starter in neural networks or even in machine learning, any of these courses, you have to visualize how this matrix multiplication works. As such, the tool begins with a bit of a complicated matrix here. So there is two matrices, there is two left and right matrices here, and each have 32 cross 32 elements, each of it have. But we are not going to work with such a huge matrix. I'm going to make it a little bit bigger so that you guys can see it better. I hope that it will allow me to do that. Yeah, it's allowing me to do that. That's a good thing. And what I'm going to do right now is I'm going to modify certain elements of this particular display. So this display provides the left matrix as a visualization and the right matrix as a visualization, and the vein in the middle. So there is a direction that is showing here. So the input from this matrices is taken from the top, and input from this matrix, the left matrix, is taken from this left side, and the values are put on this particular output. So that is what this particular vein or the arrow shows. Apart from that, you can also see there is this line which shows the rows that are available in the matrix. Okay, that is on the display. So you already saw this is the multiplication that we are doing between a matrix called as L and a matrix called as R, and we are using something called as an at symbol. This at symbol is a short form for matrix multiplication inside Torch. We'll be discussing this as we move to the Jupyter console and start practicing. But I want you guys to understand what exactly goes on once we do the matrix multiplication. And not just that, we'll be looking at various things in this small primer. I will be taking another 5 to 6 minutes on this. So there is left and there is right. So this left is all about this left matrix, and this right is all about this right matrix. And this left and right can be made into it can actually recursively grow, meaning you can have left and right inside the left, and the same way you can have left and right inside the right. So it can actually branch, it can create a tree, and a lot more stuff can happen. So let me show you that before I dive into the next step. So once I do this, you can see that here right now I had created a new matrix multiplication by using an expression like this, and here you can see that inside the left there is left and right, and there is animation, and inside the right there is right again. Okay, so let us keep this simple. I don't want to directly dive into very complex stuff right now. So my intention is not to completely discuss about this tool. This tool itself will take a lot of discussion. Believe me, you can go through this particular link. I'll be sharing this link URL with you guys. You can go through this. A lot of information is already provided in this blog. I'm not going to give anything new, but my intention here is different. To use this tool as a starting point for you guys to get a basic understanding of how to think about matrix and how to think about matrix multiplication. That's all, right? Let's move forward. So there is left matrix and there is right matrix, and both the matrix have H and W, H and W. So I'm going to change the H of the left matrix to 3 and the W of the left matrix to 3, and it becomes a 3 cross 3 matrix. So there is 3 dots and 3 dots in the rows and 3 dots in the column. Same way, you can see that it's a 3D effect, and we are going to change the right matrix also to 3.3. Did you notice one thing? If I change the height of the left matrix, there is no change in the right matrix. But if I change the width of the left matrix, so if I make this 32, you will see that automatically the right matrix grows. I did not change the right matrix height, so it grew automatically. So meaning that the width of left matrix is linked or connected with the height of the right matrix. It cannot be different sizes. So this is one of the important aspects of this visualization that I wanted to share it with you today. Both the matrix that we are building, that we are going to work with, has to meet certain rules, and why we are actually having those rules, you can see it right now in the animation. So we already see that we have a small 3 cross 3 matrix that is getting executed here, and the legends here, you can see the legend like j equal to 3, k equal to 3, I equal to 3. It looks a little bit bigger. So what I'm going to do is I'm going to reduce the size. So you can come to the deco option here, and you can actually reduce it, and also you can make the rows thickness also smaller. You can also change the sizes. So importantly, the sizes we can actually reduce it. Just a minute. Next, what I've done is I have reduced the gap. If you come to the layout, the gap, if you reduce it, if you increase it, the gap between the matrices will increase. If you reduce it, all the matrices will come close together. So since we are working on a small matrix, it is better to make these things close together. And next thing that you'll be observing is the size here. So you will see that these spheres here have some have smaller size and others have bigger size. That is because the min and the max size of the spheres are controlled by this min and max. You can actually modify this and you can see how this things changes. This min and max tells that uh, how the elements are created on the first place. And it's a 3 cross 3 matrix, and if you press control on your keyboard, you will see that you can see the value that is linked with this particular sphere. So you have to just press control and you have to scroll over that particular sphere. So you can see that there are lots of floats that is present here. It's not integers, it's all floats, and the minimum is 0 and the minimum is -1 and the maximum is 0. You can take a look at it here. So you can make it both minimum and maximum like this, and you can see the output here, and the matrix multiplication happens on top of this. Now the point here I wanted to make is, if I am going to make the height as 1, you'll see that this is a single dimension matrix and you will get a single dimension output, right? And the same way, if I change this dimension to 1, you can see that I have made it as a single dimension right now. And there are 3 elements here. You are only seeing 2, but there is an element in the middle, and we are getting a single value output. When you have an intuition like this to a level of converting to a single dimension, and you can see what exactly happens, you can actually animate it and see. That's one of the important aspects. You can actually do the animation. So once you start the VM product, you will see that the values from the top, that is from the right matrix, is getting projected down, from the left matrix is projected to the middle, and both of those are multiplied and then added to get the matrix multiplication. With this visualization in your mind, what we are going to do is, we are going to next enter into Torch, and we are going to try and work with various kinds of matrices with various shapes. Before that, I just want to add one more point. I want to actually increase it to 3. You'll see that the animation continues. So let me actually slow down the animation so that you can see what happens. And I am also going to make this 3. So that's how the things change. Next important point I wanted to mention here is that the animation that we are using has vertical product, and we have MV product, and we have VM product, and we have VV product. So you will see that the product that happens can happen in various axes, and all those options are already provided here. And you can see the dot product also. So when you are doing a dot product, you can see that the dot product happens between the matrix. It happens between a vector and a full matrix. And when such a thing happens, you are going to see that the matrix multiplication can be done in various ways. All these things you can actually experiment in this simple tool. Another point that I wanted to mention here is that when we are going to have 3 by 3 matrix, and we are going to have some 10 batches, then you can visualize that same 3 by 3 matrix will be copied 10 times, and each and every time one batch or one matrix will replace here and a new matrix multiplication will be created. So each time one new matrix comes in, a new matrix multiplication output will be created as a separate matrix. So I will explain this as we dive into the shapes and sizes of matrices or tensors in next couple of minutes. If you are curious that what exactly this tool is capable of, then I would like to show you this particular link where a complete attention layer has been created and the input has been sent. You can see that 3 inputs are being sent, along with the weights are also being sent, and we are getting an output here. And you can see how the output gets modified, and also if you want, you can actually do the animation also, and you can see how the exact steps happen. So if I start creating animation, it will start proceeding here. Since this system is not that much capable, once I start the animation, immediately the system hangs for a couple of minutes, but you can see the animation moving here. It uses the CPU for doing the processing, so the system is going to take a lot of effort. So keep that in mind. Ensure that you don't do this on Raspberry Pi. Raspberry Pi will not be able to take this much amount of load. The idea here is that I want to show you what is capable in this tool. So I'm bringing up the Raspberry Pi now, and I'm going to SSH into it so that I can start the Jupyter server. And once I will be using this command. I had explained about this in the earlier videos. So the server is up, and after this you have to give it a moment's time, and you will see that it is able to spawn the server and give us the link that we can use. So once the server has spawned and its log has been written, it will start coming out like this inside the jupy.log. So you have to give it a couple of seconds, and once it is up, you can just click on this and it will open in the Jupyter lab will open in the separate browser tab. Once you have the Jupyter lab, we can go into the console and we can start importing and work on the torch by importing it. So I'm going to select the kernel. You see that the console is coming up, and I'm going to import torch. So to start working on that, in order to execute, you must be using shift enter. What we are first going to do is we are going to first of all explore the shapes of the tensors. Once you are really comfortable with the shapes, then and only then go into transforming the tensors, or else it is one of the easiest ways to get lost when you're going to work with especially machine learning. So just be very comfortable with it, and if you are not comfortable, try to practice it. Maybe not this video, try to get some more videos, some more different kinds of matrices, and try to practice. So that's one of the important points I wanted to highlight here. Watching a single video or working on this matrix shapes for 1 hour a day is not going to cut it. We have to work on it again and again. It takes a considerable amount of effort, and you already saw someone had created one of the wonderful visualizations, and they had created a complete tool that can run inside the browser itself, and they have understood it thoroughly. So that's how they are able to create it. And the intention of this tool, the Matmul tool, is to make the visualization 3-dimensional. That's the right way to visualize matrix. Even I was thinking the same. If you're going to make this left matrix and right matrix like this on a paper, and if you're going to keep it adjacent, it's not going to be intuitive. Once you make it into 3-dimensional, things start really showing up. Let's now jump into creating a simple 1-dimensional tensor. So 1-dimensional tensor and 1-dimensional vector and 1-dimensional matrix, there cannot be a 1-dimensional matrix. It can be only 2-dimensional matrix. It can be a 1-dimensional vector. Sorry about that. Let's begin. So I'm going to start with a single dimension tensor. So let me do a torch.tensor, and I'm going to manually create the tensor first, and I'm also going to create it using the rand function, so that you can see how the things are different. And I'm going to use the d type as float. I'm going to give that manually because, as I told earlier, keeping track of the data types are very important. You'll see that the torch tensor has been created 2, 3 and 4. It will be of type float tensor, and next I am going to create one more tensor, but this time it's going to be a random tensor. So torch dot random, if you since we have already installed hinterland extension in this particular RPI, we will be able to get this kind of auto completion. So you might have to press tab in case of Raspberry Pi, but if you're using the same kind of JupyterLab in a powerful Linux machine with lots of RAM, then you don't need to do that. It will work by default. In case of RAND, you can check the various information that you need to give. We need to give the size of the tensor that we want. So before we go and ask for the size of the tensor, let us first of all see what is the shape or the size of the tensor that we already have. And once I execute this, you will see this is a single dimension vector, meaning it's not actually a matrix by any way, it's just a vector. What does this mean is basically that it's not two-dimensional. But if you are going into torch random, so for an example, if I go and create random, and here it will ask for a size. So if I do, you will see that it is asking for a size, and the size is actually of it can be int, so it's just asking for an integer. So if I am going to give an integer here, if I am going to say 3, and if I give the d type, you don't need to give the d type, but still just give the d type, so to avoid any kind of surprises. Torch dot float 32 and execute it, and then if you see the size here, you will see that the output that has been given by the rand 3 is same as the output that we got created here. We have to go from the beginning, so we have to start from a single dimension vector and then move slowly towards more complex steps. So what we are going to do next is we are going to do a simple dot matrix multiplication. So if you guys are new to dot matrix multiplication, then I would suggest that take a look at your math books. You will be able to find it out. Now here we are not going to get into the math, but we need a matrix. For getting a dot product, we need a matrix that is of size at least 3 rows and 3 columns. So I'm going to say torch dot tensor. I'm going to build the matrix now, and I'm going to build 3 rows first. So this is a 3 row, and inside the 3 rows I'm going to build 3 columns. You see how it is getting built now. The idea of building the matrix like this step by step can actually make you understand things very easily. So I'm also going to check the size so that you can see how the size of the matrix is. And once you execute it, you will see that it is a 3,3 matrix, right? And I'm going to create one more matrix, but this time I'm going to create it using torch.rand, and I'm going to give it a size of 3,3, d type of float torch.float 32, and d dot size. So every time I'm creating, I'm actually looking at the size to ensure that we can visualize what's happening. So this 3x3 tensor that we are seeing here is same as what we visualized in this particular area. So this is a 4 rows 3 columns. This is a 3 row 4 column matrix. Here we have created 3 row 3 column matrix. And what we are going to do next is we are going to try and multiply that 3 row 3 column matrix with a vector. A vector is having only single dimension. Let us go to that vector multiplication. Vector matrix multiplication. So we will say vmul. That's a more descriptive name that we have got there, vmul. And what we are going to do is we are going to say a multiplied with C. And what do you expect? Will it get executed or not? So whenever this kinds of execution happens, there is always a chance that if you're wrong, if your dimensions are wrong, then you will not get the answer. It will not execute. The multiplication will fail, and there will be error telling that the shapes are not matching. In this case, this is a single vector that we are having 2, 3, 4, and we are multiplying that on this matrix. And you see that it multiplied 2 with these values, it multiplied 3, it multiplied 2 with this column. So it multiplied with 2 with 1, 5 and 9, 3 with 2, 8 and 62, and 12 in the same way. Why we are doing this way is to understand how a regular multiplication and how a matrix multiplication works. So now let us try something little bit, forward. So how is matrix multiplication different from the regular multiplication, and can we do the matrix multiplication on this single vector? Is that possible? Sorry about the disturbance. So let us try that. In order to do matrix multiplication, we have to start by vector. This is going to be vector matrix multiplication. So we are going to take a vector that is single dimension, and we are going to multiply with the two-dimensional matrix, that is this one. So just to show you how the matrix is, I'm going to print it out so that it will be easy. So this is the two-dimensional matrix. We are going to do matrix Matmul on these two. So I'm going to say torch.matmul, and you'll see that there is a function called as matmul, and if you do a shift tab on this, you will see that it has got a lot of information. So if both tensors are one dimensional, the dot product is written. So you see, this is one of the points that I was trying to talk about. Depending on how the dimensions of the vectors, how the dimensions of the tensors are, the output is going to be modified. So if the both arguments are two-dimensional, this is going to be the case. Here, what we are going to try right now is, if the first argument is one-dimensional and the second argument is two-dimensional, one is prepended to its dimension for the purpose of matrix multiply. After matrix multiply, the prepended dimension is removed. So basically, when I am going to do this vector, so A is a vector, as you already saw, A is a vector, and I am going to multiply it with the two-dimensional tensor C, right? And this is going to go through. We saw that it can be done, and once we go through this, okay, so we see that there is an issue. So what is the issue here? The expected M1 and M2 have same D type. As I already told, these issues are pretty common, so that's why you have to keep the data type in line. So the data type of C matrix that we created was long int. It's not float. So I'm going to create the C data type again and C tensor again, and I am going to make it as float 32. And once after that, if I execute this, it will go through. So you see that it went through, and you see how easy it is to operate it on Jupyter console. Believe me, in VS Code, when you're going to run it in scripts, it is in fact way more easier. However, due to the Raspberry Pi RAM constraint as well as the temperature constraints, I had to move to Jupyter console. Anyway, so you see that after we multiply the vector, that is the vector that we created here, 2, 3, 4, with this matrix that is 2D tensor, we got an output that is a vector. You can take a look at the size also. Once you build your own tensors and take a look, this is one of the key aspects of practicing. Once you build your own tensors by your own fingers inside the Jupyter console, you will see what kinds of mistakes you are making. Even here I'm making mistakes, right? The faster you are able to do these mistakes and better, faster you are able to do these mistakes, and more errors you are going to face when you are going to actually build a big model or a pipeline where you are going to train a model, at the time this is going to be way more easier. So this is kind of a starting point where we worked on the thinking of how to work with matrices and how to visualize matrices, and we are actually going to go forward in the next video to further work on Matmul. We will also work on the operator broadcasting options. We will also start stacking and concatenating, find why stacking is different from concatenate, work on squeezing and unsqueezing, etc. Till the next video, take a look at the visualization tool that we introduced in this particular discussion, and try to work on the visualization tool, that is the matrix the mm tool that we saw here. You can take a look at that. And second thing is, try to create basic matrices based tensors in Jupyter console, and see what kinds of inputs are required, especially if you go to Matmul. See what kind of options are available and how you can modify the inputs. So till the next video, stay tuned and have a great time, guys.